Hello everyone, I am Shashwat and today I am going to talk about FCS scheduling, design and evaluate. Introduction: CPU scheduling is a method used by the operating system to decide which process should run next on the CPU. Since multiple processes exist and only one CPU may be available, scheduling helps in improving CPU utilization, reducing waiting time, increasing throughput and managing fairness between the processes. First come first serve. This is the simpler CPU scheduling algorithm processes where processes are executed in the order when they arrive, like it works like queue, first in first out. It's a non-preventive where one process starts, it completes without interruption. It is very easy to implement but may cause conway effect. The main objective is to design FCS scheduling simulator and create a C program that accepts dynamic arrival time and burst time and analyzing whether FCS is suitable for the real-time systems. Coming on to the experimental setup, programming languages used is here the implementation of the FCS scheduling algorithm is done using the C programming language. So C programming language is used here because it provides fast execution, easy handling of arrays and structure, precise control over the memories, suitable for system level algorithm simulation. The tools and environment here used are C compiler is a tool we have used. For execution environment, the program was compiled and executed in a C online compiler. The OS used here is Windows and in Android phone. Dataset description. For each dataset consists of processor, and for each processes the field are arrival time, burst time, process ID. Arrival time is the time at which the process enters the ready queue. Burst time is the CPU execution time required. Process ID auto assigned as P1, P2, P3 and P4. The data sets are entered manually time during the program execution. Coming on to the implementation, here there are 5 steps. First steps, we have to start the program. Begin by including the necessary header files like stdio.h. Define the structured processes like process ID, burst time, completion time, arrival time, start time, waiting time and turnaround time. Step 2. Input the number of processes. The program asks the user to enter the number of processes. An array of the structure is created to store the details of each processes. Step 3. Take the input from the processor. For each process, align a processor, read the arrival time and read the burst time. Step 4. Start the process by arrival time. Set all processes in increasing order of the arrival time. The process that comes first gets the CPU first. Step 5. Calculate the scheduling parameters. Start time. If the CPU is idle, start time equal to arrival time. If the CPU is burst, start time equals to current time. So the observations of this experiment are first come first serve execute process in the order they arrive. If a long process come first, all others wait longer. Waiting time and turnaround time depend on mainly on the arrival order. CPU becomes idle only when no process has arrived. First come first serve is simple but not efficient for processes with varied burst times. Average waiting time increases when early processes have large burst times. Coming on to the flowchart is as we have to start the program, input the number of processes, input arrival time and burst time for each processes, start the processes by arrival time. For each processes, calculate check the start time ST, CT, WT and TAT, display the table, calculate the average WT and TAT and end the program. So this is the program. So this is the program code which helps in the to check the average waiting time and average turnaround time. When we run this, so here the number of processes are 4 and the arrival time and the burst time of the processes are as so on. So this is the average waiting time of the 4 processors which we have given. It is 2.50 milliseconds, and the average turnaround time for the this processes are 5.25 milliseconds. So this is the program output. And coming on to the conclusion, first come first serve is not recommended for real-time applications. It provides yes, SRTF provides the best performance with a lower waiting time and fast response. Thank you.